All right, let's talk about the unsung heroes of our digital lives, manual software testers. They're the ones working behind the scenes, making sure the apps and websites we use every single day don't just work, but feel, well, flawless.
You ever just open an app and it just works? No glitches, no crashes, it's just seamless? Well, there's a really good reason for that. Before that app ever got to you, a real person, a tester, was paid to try and break it in every way imaginable. So how exactly do they do that? Let's dive in.
So, at its heart, software testing is basically quality control. It's a deep dive investigation to make sure a piece of software actually does what it claims it's going to do. Think of testers as digital detectives. They're on the hunt for clues. We call them bugs that could completely wreck your experience as a user. Okay, so when these digital detectives start their investigation, they don't just have one way of looking at things. They actually have two really different perspectives, and it all boils down to one simple thing: what they can see and what they can't.
Let me give you a quick analogy to make this super clear. On one hand, you've got what's called black box testing. This is kind of like being a food critic. You're tasting the final dish, the app's features, but you have no idea what the recipe is. You just care if it tastes good, right? If it works. Then, on the other hand, there's white box testing. Now you're the chef. You have the recipe, the actual code, and you are going through it line by line to make sure every single ingredient is perfect.
For now, let's focus in on black box testing, because honestly, it's the most common approach you'll see. The great thing about it is you don't need to know how to code, which makes it super accessible for a lot of people. The entire focus is on the user's experience. You're just asking, if I do this, what happens? So you put in an input, like your username, and you check if you get the right output, like, actually logging in. It's all about making sure the software keeps its promises to the user.
Now, you might be thinking that testers just sit around clicking buttons randomly, trying to break stuff, but that's not it at all. Their work is actually super structured, and the main tool they use to create that structure is something called a test case.
Yeah, a test case is literally the tester's blueprint. It's a document that spells everything out, exactly what to test, the step-by-step process for testing it, and, this is key, what success is supposed to look like. It's what takes a potentially chaotic mess and turns it into a really methodical, organized process.
Let's look at a really simple example we all know, logging into Gmail. So you see here, the test case gets a unique ID, just for tracking. It lays out the scenario. We're trying to successfully log in. It lists any prerequisites, like, you need a real Gmail account to start with. Then it gives the exact steps. Go to the site, enter your email, click Next, and so on. But the most important piece of this whole thing is the expected result. This is the finish line. This is our definition of success. If you end up in your inbox, fantastic, the test passes. If anything else happens, well, it fails.
So, what happens when a test fails? Well, that's when things get interesting. This is the moment a tester makes their most important discovery. They've found a bug.
And this is a huge moment. See, a bug isn't just some random glitch. It's proof. It's a documented, verifiable gap between what the software is supposed to do and what it actually did. And once that bug is found and documented, it starts a whole journey of its own. We call this the bug lifecycle, and you can think of it like a patient's chart at a hospital. First, a tester reports the bug, so its status is new. Then it gets assigned to a developer, kind of like assigning a doctor. The developer opens it up to start working on a fix. When they think they've solved it, they mark it as fixed and send it back to the original tester for a retest. If the tester confirms the fix works, awesome, the bug is closed. But if it's still broken, it gets reopened and the whole cycle starts all over again.
So, looking at a chart like this gives you a pretty good snapshot of a project's overall health. Obviously, a big chunk of closed bugs, that's a great sign. But if you see a ton of new or in-progress bugs piling up, that can mean a couple of things. Maybe the team is finding a lot of new problems, or maybe they're just getting stuck trying to fix the old ones. Either way, it's a really important at-a-glance look at the software's quality.
Okay, so structured test cases are absolutely essential, right? But some of the nastiest, most critical bugs aren't found by following a script. They're found when testers go rogue, when they rely on something that's uniquely human, their intuition.
And this quote from the testing expert Cam Kaner just hits the nail on the head. He says, no matter how many test cases you've created, you will run out of formally planned tests. Trust your instincts. That really gets to the heart of it. You just can't predict everything. At some point, you have to trust your gut and just explore.
And that's exactly what we call exploratory testing.
It's like a freestyle approach. The tester is learning, designing tests, and running them all at the same time. It's all done on the fly, and it's driven by pure curiosity and experience. Here, the goal isn't just to check off boxes and see what works. The goal is to discover what breaks in weird, unexpected ways that nobody ever thought of. So you have these two styles, and they're really perfect complements to each other. Scripted testing is there to confirm what you expect to be true. It's structured, it's predictable, it's reliable. Exploratory testing, on the other hand, is all about discovering what you didn't expect. It's creative, it's adaptive, and it finds those bizarre problems that no script could ever predict. To get really great quality, you absolutely need both.
All right, so as we start to wrap this up, let's just boil this all down to a few key takeaways, the essential best practices in this whole quest for quality.
You know, there are a few things that really separate good testing from great testing. Your test cases have to be crystal clear and easy to understand. They have to focus on what the actual end user cares about. And you really want to aim for what we call maximum test coverage. Basically, test as much as you possibly can. On top of that, good tests are repeatable and they don't mess up the system for the next test. That kind of discipline, that's the real foundation of quality software.
And that leaves us with a really interesting question to think about for the future. You know, as AI gets better and better at writing and even testing code, it's easy to wonder, will we even need human testers anymore? But as we've seen today, the best testing, the stuff that finds the really nasty bugs, relies on things like creativity, intuition, and just plain human empathy. So as the machines take over all the predictable, repetitive work, maybe the most valuable tester won't be the one who thinks like a computer, but the one who thinks most like a human.